All right, today we're diving into something that's kind of like the invisible foundation for all of science: ethics. This is the stuff that decides whether we can actually trust what scientists tell us, or if it's all just, smoke and mirrors.
So, yeah, let's just get right to it with the biggest question of all. Can we really trust science? Well, the answer to that really hangs on the ethical principles we're about to break down. Okay, so here's our game plan. First, we're going to tackle why ethics even matter in the first place. Then we'll look at what I like to call the ethical compass that guides researchers. After that, we'll get super practical with the do's and don'ts, and we'll wrap up by looking at what happens when science goes wrong.
Right, section one. So, why is this so critical? I mean, this isn't just about having rules for the sake of having rules. It's about the very heart and soul of science itself, its integrity. Okay, this slide really lays it all out, doesn't it? It's a tale of two worlds. On one side, you've got ethics, which means respect for people, for colleagues, for the work itself. But without ethics, man, that's where things get dicey. Public trust just crumbles, and the whole search for truth gets compromised. The stakes are just incredibly high. So let's get a little more specific. Why do we need these rules? Well, it boils down to three really practical things. First, ethics make sure that scientists are transparent, showing their work so others can check it. Second, it pushes for super rigorous methods to keep bias and errors to a minimum. And maybe most importantly, it guarantees that they handle data responsibly to protect the people who are actually in these studies. All right, moving on. Let's talk about the tools researchers actually use to figure this stuff out. Think of it like an ethical compass, a set of core principles that point them in the right direction when they face tough decisions. First on our compass is respect for autonomy. And this one is huge. It basically means a research participant is never just a number on a spreadsheet. They're a person who has the absolute right to know what they're getting into and to say yes or no freely. It's all about informed consent and privacy. Next up, we have this pair of principles that work together: beneficence and non-maleficence. It's really a balancing act. The goal is always to do good, to create something that helps people, but never at the cost of harming the participants. So the potential benefits have to clearly, absolutely outweigh any risks. Then we have research integrity. You can think of this as the promise of authenticity. It's the simple but profound commitment to being 100% honest in your work. That means no making stuff up, no fudging the numbers, and definitely no stealing someone else's work. And finally, there's objectivity. This is so crucial. It means science has to be a search for the truth, whatever that truth may be, not a mission to prove what you already think is true. Researchers have to be able to step back from their own beliefs and just let the data do the talking. Okay, so we've got the big ideas, the principles. But how does this actually play out day to day? Let's get into the nitty-gritty. This section is all about putting those principles into practice. So here are the four big do's. First, be transparent. Share your data and methods so other people can see if they get the same results. Second, give credit where it's due. Science is almost always a team effort. Third, be open about any conflicts of interest, like who's funding your study. And last, just follow the rules of your institution. Simple stuff, but it's what builds trust. And now for the flip side, the don'ts. These are the absolute red lines you just don't cross. Number one, don't manipulate your results to fit a story you want to tell. That is a recipe for disaster. 2, don't plagiarize, ever. 3, don't just ignore data that goes against your hypothesis. You have to deal with all the evidence. And 4, don't try to game the system by, say, publishing the same study over and over in little pieces. So, what happens when someone crosses those lines? In our final section, we're going to look at the ugly side of things, the real-world consequences when ethics get thrown out the window. The official term for this is scientific misconduct. And while it covers a lot, it really zeroes in on what you might call the 3 deadly sins of research: fabrication, falsification, and plagiarism. These are the big ones because they don't just mislead people, they can send entire fields of science down a rabbit hole, wasting years of time and money trying to build on a lie. Okay, so let's break down 2 of those big ones: fabrication and falsification. They sound similar, but there's a key difference. Fabrication is literally making data up out of thin air. It's pure fiction. Falsification, on the other hand, is when you take real data and you mess with it. Maybe you delete the inconvenient results, or you change a few numbers to make things look better, One is inventing a fantasy, the other is distorting reality. Both are catastrophic for science. And this image is a perfect example of what fabrication looks like. Look on the left, that's the real data. See those gaps? Those are times when they didn't get a measurement. Now, look at the right, the version that got published. Suddenly, those gaps are filled in with nice, neat data points that were completely invented. It's fraud, plain and simple. All right, on to the third major sin, plagiarism. And we need to be clear, this is way more than just copying and pasting a sentence from Wikipedia. It's taking any part of someone else's work, their ideas, their writing, their images, even their computer code, and passing it off as if it were your own. And it can show up in a bunch of different ways, right? You've got the obvious stuff like copying text without using quotes or a citation, but it also includes just rephrasing someone's ideas without giving them credit, or even translating something from another language and pretending it's your original thought. The bottom line is always the same. You didn't give credit. Now, besides those big three, there are other shady practices out there. Salami slicing is a funny name for a not-so-funny thing. Taking one decent study and chopping it into a bunch of tiny, less impressive papers just to get more publications on your resume. And then there's all sorts of games with authorship, like adding a famous scientist's name to your paper even if they did nothing, or leaving off the name of the junior researcher who actually did all the work. And all of this brings us right back to where we started. Every single one of these ethical breaches, from the tiny to the huge, does the exact same thing. It chips away at public trust. When the ethics fail, the integrity of science goes with it, and that's a loss for every single one of us. So, I want to leave you with a question to chew on. We live in this publish or perish world, where researchers are under insane pressure to produce results. With that in mind, what do you think is the single biggest threat to scientific honesty right now?